Yeah, so I have sort of the cocktail party version of relativity, okay, which I think anyone can grasp. So the basic idea is that you can model material particles, like electrons and protons, as being waves that go around in circles, okay? And just imagine that you make a clock that ticks every time the wave goes around in a circle, okay? And it's traveling the speed of light going around in a circle, okay? So you take a stationary clock and it's going tick, tick, tick every time the wave goes in a circle. Which is very fast, by the way, it's like less than a nanosecond to go around. But it's ticking every time the wave goes around in a circle. And then you take a moving clock, which now instead of a circle, it's going to follow a helical path. So it's going to have to travel farther to make a full cycle around the circle. And so because it has to travel farther, it will tick slower. So the rate that a moving clock will tick is slower than the rate that the stationary clock ticks. Okay, and that's it. Lately, I've been more interested in fundamental physics and education. And I guess my basic idea is that things that are very complicated to explain using quantum mechanics and current theories, I think maybe have simpler explanations. So I've gotten very interested in coming up with a different description of physics than the standard one that people use, one that's more understandable by ordinary people, have a little different take on relativity, which it's actually based on things that were, it's actually based on ideas that were developed maybe 200 years ago, comparing light waves with other types of waves, and in particular with waves in a solid. So there was this whole idea back then that the universe itself was actually a solid, and light was some kind of wave propagating through the solid. So I've been investigating that idea and trying to extend it and adapt it to all the modern evidence. I would say there's a piece that's missing, which is no one ever actually solved these old models of the universe being a solid. No one actually can predict if that were the case, what would be the result. Science is an adventure, and it's always fun to think about things in different ways.